Hi, Professor. This is Hemant from Group15. Other members of my group are Pranit, Priyanka, Shiva, and Pradeep. So our project name is Infrastructure for Urban Traffic Control Systems using a cloud computing. Today in progress presentation, I want to give a short note on project project analysis. It's my part of the in progress presentation. So motivation like emerging cloud computing technologies allow for an inexpensive use of mass quantities of storage, bandwidth, and computing resources use the pay-per-use model on which it thrives. So we can expand or decrease the storage space as per the requirement. The adoption of broadband infrastructure in various forms across cities allow for high bandwidth, low latency, high reliability connections to the internet. So urban traffic control systems are designed back in a time when the only form of data transfer were the high latency. Combining these ideas and focusing more fine-grained infrastructure as a service through the use of Amazon Web Services platform to make the case that the implementation of urban traffic control systems on the cloud is a feasible venture. So the main problem we selected is controlling traffic. So for this, the most accurate and efficient way is adaptive control system, which guides itself or which process the real-time data and gives the logic by itself and keeps the flow without any problem. So the main design and implementation of a reference architecture is a SCADS. So SCADS means Sydney Coordinated Adaptive Traffic System. So it's a intelligent traffic system. So before going to project analysis, I want to give a short note on and SCADS. So how it works, SCAD adaptive traffic system works. So it's a tariff where the inputs and everything takes here, and the traffic signal controller process the inputs, provides data to SCADS, makes the decisions and control signals. So these sends the signals to the data to the regional services. These services are applied or installed at every junction or at every point, every interjection point. So it collects the regional area and it calculates the data and sends to the central manager. It's the main brain of the system. So it manages the regional services. It's the head of everything and conference regional services issues infrastructure to regions. Sorry for that. So it's basically it resends that to regional services and that to traffic signals. So in this way, the traffic will flow and it will be more safe in manner. So project analysis. So from that, we can say that smart urban control system is capability is a key factor to the success of smart city because it enables many smart transportation services. The objectives of project will involve addressing main difficulties such as reducing the average wait time, controlling congestions, prioritizing emergency vehicles, ensuring the requirements of an intelligent traffic system are designed to offer insights on the goals of the infrastructure. So basically, it will be a how can we say that? It's a small demo of that stimulator in form of stimulator or something we want to represent in a form of app when we give the inputs. So it will control the traffic. I mean, controls the app in a more efficient way like that. So the success and development of the project will be based on the ability to develop and adapt to traffic signal controls. That's it from me. Thank you. And the remaining parts will be explained by our team members. Thank you.
Hi everyone, myself Priyanka Ainala. Today I would like to explain alternative solution analysis for infrastructure of urban traffic control systems using a cloud computing. Here an infrastructure supporting vehicular network can be developed as an alternative solution in order to reduce the traffic congestion. Moreover, A smart traffic signal control system is designed and implemented, which supports several smart city transportation applications like transport signal priority, adaptive traffic signal control, eco driving supporting, and message broadcasting. And also, a roadside unit controller can also be developed, which focus on the control algorithms and system architecture. Here are some pros of an automated system. We can also combine these systems to work with GPS, laser radars, sensors, which either increases the safety of the pedestrians or warn against the potential vehicle traffic threats like irregular traffic flow. And also the cost can be reduced as only one traffic light is used at an intersection. And moreover, it also gives emergency services like green light, which prevents the accidents. Here are some of the disadvantages. There is a chance that these systems can be hacked, and also there is a issue of privacy as people feel that they are being watched or monitored whenever they go through the traffic lights. And also it requires lengthy consultations, possible land purchases or service agreements, and we have to be rolling programs over several years. Overall, these alternative solutions seems practical and helpful in many cases, but it requires a high level of understanding and attention to be implemented. Thank you, everyone.
Hello, I'm Shivadatha Gajala. I played a role as a project designer for the project called Infrastructure for Urban Control System using a cloud computing. Before before starting a project design, we have a lot of questions that need to be answered, like whether we are able to do the project in a limited time or not, whether we are able to do the project in a given budget or not. Are we maintaining the data confidentiality? That is nothing but are we maintaining or going to keep the data privacy or not? Are we maintaining the minimum latency in between JC and MC? JC is nothing but the junction controller, and MC means main controller. That is nothing but like gathering the data from the sensors, processing the data in the real time, and giving the report as an output in the real time. Is this whole system is able to tolerant to the faults, whether it can recover by itself? These are the few most important questions that need to be answered before the project design. For for this project, we have considered the model called multi-model traffic flow stimulator. It is a model that is developed by PTV, a German company, and the model is called as VISSIM. By this model, we can stimulate the cyclists, pedestrians, and even rickshaws. Rickshaws are the small maneuvering vehicles that can be seen in the countries like India, Bangladesh, Pakistan. Yeah, and we have used a web service from the Amazon called Amazon Web Services. So we have used AWS because of its speciality. That is like we can control whole individual unit computation, storage, and everything. We have total freedom to scale the project and flexibility as well. As a global requirement, the system must be made in a modular fashions, allowing the replacement of parts if required only. The function architecture of this project divided into three separate components: vSIM components, JC, and MC. JC is junction controller and MC is main controller.
Uh, Hi, Professor. Good evening. Myself, Pranit Siddhartha Kaja. I'm from Group 15. My group leader is Hemant, and my team members are Priyanka, Pradeep, and Shivadatta. And coming to our topic, infrastructure for urban traffic control system using a cloud computing. So, for this thing, I have chosen a project progress evaluation. I want to show our project progress evaluation based on 6 different categories. Like the first one is discussions. Based on the design section, evaluation determines if urban traffic control are viable to run from a cloud computing infrastructure and comments on each outcome. to warrant how the new design solutions will meet the project specifications will entail various processes. And the second thing is solutions. In a meeting the initial user requirements and objectives, the newly designed solutions will have to be based on the process and goals outlined in the design section. This can involve handling each controller differently and later creating a connection between the main junction controller and the regional manager. This will ensure that SCATS main control requirements as are met. And coming to the SCATS, it is a Sydney Coordinated Adaptive Traffic System. It is a intelligent traffic control system. Actually, it's like if it's based on the inputs they got, it's sent to the SCATS, and from there we'll get some solution, and from there we'll get the output. Then output will be given as a signal systems. This is a outline of our project. And coming to this third part, it's resources. The main resource for is AWS, because AWS is very well established, and it will be very user friendly for many students. And also some of the resources that will need enough attention include the quality assurance tester and the cloud application developer. This will play a major role in understanding the tools, time and cost to guarantee success. Going to the fourth point, features and functional requirements. There will be inclusion of mass quantities of storage, computing resources and bandwidth. The broadband infrastructure will need to be adopted to ensure that there is a steady connection, which is essential for the overall running of the system. Especially, it must contain the combination of infrastructure services as well as Amazon Web Services platforms. And coming to the fifth part, it's a feasibility. Also, there is a need for the implementation of reference architecture dubbed in the urban cloud framework, along with the placement of SCATS atop this framework. This will demonstrate the feasibility of this project. And coming to the risk of an instance will resolve on the SCATS main controller by simply starting another one in its place. Yeah, this is our overall project progress. Thank you.
Hi, Professor. This is Pradeep Kumar Chidala. Our report is about infrastructure for urban traffic control systems using a cloud computing, and I'm discussing about the future plan. So here are some points of describing about the future plan. Just a second, Professor. I described some of the points. Like in the future plan for the implementation of the solution, this will include loosening the coupling between VISSIM and UCF. This will ensure that the simulator can be plugged in UCF just by loading the DLL representing the simulator's component, in our case the VISSIM component. And the second point I'm describing about next, it will enter the dynamic loading of the controller DLLs. This is an effective verification of the system in the sense for SCATS junctions controller class, which extends the UTC junction controller, is defined as a VISSIM wrapper class. The third point I would like to discuss, source code would perhaps not be available to everyone, and to move forward the notion of the traffic simulation as service and the traffic control as a service. The final step of the implementation, it will need the inclusion of simulation ID in the abstract sim event class is exactly what was intended for, as it allows for data to be aggregated as per the simulation basis. And my team members are Siddharth Kaja, Hemant Akki, and it's me, Pradeep Kumar Chidala, Sivandatta Gajjala, and Priyanka Ainala. Thank you, Professor.